Let's talk about Laplace transform. Laplace is a method used by engineers to solve a circuit problem. And it's really most engineers use Laplace to solve any problem. I know in circuits 1 we learn how to solve a circuit that has a DC for a source. In circuits 2 early, a month, 2 months ago, we learned how to solve a circuit that has a sine or a cosine for a forcing function. So what about if your circuit doesn't have a sine or a cosine or a DC value? How do you solve it? Also, can I use this method when my source is DC, when my source is sine, cosine, t, e to the minus alpha t, anything you want it to? The answer is yes. And so the way Laplace works is if you have a circuit that's in time domain, first thing we need to do is change it using Laplace, solve it in Laplace, and change it back to time domain. That changing back is called inverse Laplace. Imagine if you have a problem here to solve. You have an engineering problem and you want to solve it, but here's the problem. It's written in English and you're looking at it and said, I have no idea how to solve it. But you know your neighbor, somebody told you have a neighbor just moved in. Brilliant. But that neighbor doesn't speak English. So what do you need to do? You need to take this problem, change it from English to their native language so he or she can solve the problem in their language. Then they have to send it or change it back. Somebody got to change it back for you to English. That's really the process. So that's what Laplace is. We're going to take the problem, first change it from time domain to complex frequency using Laplace, solve it in complex frequency, change it back to time domain using the inverse Laplace. So how do we change the problem from time to complex using Laplace? Let's see. If you look in most math books, they'll say the Laplace of f of t. They'll give it the name f of s. And that's really the integral from negative infinity to infinity, e to the minus st times f of t dt. Now for you and I, when you build a circuit, the circuit was not built minus infinity years ago. So really our circuit, so when you have a DC source or when you have a sine function, so when you have a DC source, we go your source f of t equals 5. What that means really, when you walk into the lab, that's t equals to 0. It has a value of 5 when t is greater than or equal to 0, but it was 0 when t was less than 0. Before you came into the lab, that circuit wasn't even built. So when you build the circuit and you connect the source to it, that's t equals to 0. So we're not going to be going from negative infinity. It will be going from 0 to the time there. So let's see. If I want to find the Laplace of that, of a DC source, so the Laplace of that is going to be the integral, I'll stick with the definition, negative infinity to infinity, of e to the minus st times 5 times dt. Well, we know we can take the 5 outside. And again, this will start from 0 because my function starts when you walk into the lab all the way to infinity, e to the minus st dt. Now the integral, there's the 5. The integral of e to the minus st, you're doing the integration with respect to t. So s is a constant. So it's 1 over negative s e to the minus st as t goes from 0 to t to infinity. So that's 5 over negative s. That's an s here. Let's plug in the limits. The upper limit first. That's e to the negative infinity minus e to the 0. Well, e to the negative infinity is 1 over e to the infinity, and that's a 0, minus e to the 0, which is a 1. So the Laplace of 5, it's 5 over s. Let's try another one. What about if you want to find the Laplace of e to the minus alpha t? We call that f of s, and that'll be the integral from negative infinity to infinity, e to the minus st times e to the minus alpha t dt. Again, as I said before, in circuits you don't go back to negative infinity. We start from t0, so that's from 0 to infinity. When you multiply, you add your exponent. I can factor the minus sign out. S plus alpha t dt, and the integral of that is 1 over s plus alpha times e to the negative s plus alpha t as t goes from 0 to infinity. So you plug in the limits, 1 over s plus alpha, the upper limit e to the negative infinity still, minus e to the 0, e to the negative infinity is what? That's 0. E to the 0, that's a 1. I'm missing a minus sign here. There should have been a minus outside. That's a constant here, all of that. So what are you going to have? You're going to have 1 over s plus alpha. That's an s here. It looks like an 8. Where's my eraser? That's an s. So that's the Laplace of e to the minus alpha t. One over s plus alpha. Let's do another one, but I'll stop the video. I'll start another one.